they're going to pass out some bottles of Coke, but you, under no circumstances are you to open them here, otherwise my head will be cut off, because all I want you to do is look at the bottom, okay? And then when you go out, you can drink as much of it as you like. So I'm kind of starting because I like to start on time, and it's in my watch it's already 5. But if there's a formal starting process, I'll be happy. So I'll just talk about things in general. I joined IIT 51 years ago. Can you guys think that far back? How many can think that far back? Okay, and I've been having a great time on campus. I gave a talk yesterday at the Department of Management Sciences on value creation. And I've been so impressed. I went to the swimming pool, and you guys might not know it, but we did the digging for the swimming pool as students. So you guys are now enjoying the fruits of. This is another guy who did some digging, and there are some guys who poured concrete and did all of those things. Yeah. The swimming pool, there was all kinds of things that we did.
Mind if I crack a light one?
Yeah.
Okay. Actually, these guys dug the pool and we had to prepare it.
So, should we get started or? Huh?
Shall I give you an intro?
If you want to. Okay.
Good evening, everyone. Thank you for joining us this evening for this lecture. So, Gautam Mahajan sir is a BTech 1968 batch mechanical engineering, and he was a past president of Indo-American Chamber of Commerce. He is currently the president of Interlink company, and he is also a customer value management pioneer. So very interesting things to tell to you all. So I request sir to continue.
So now formally good afternoon, good evening to all of you. I'm basically going to go back into a memory talk about some of the things I've done in engineering. How many of you are mechanical engineers? Okay, and how many are from other fields? Okay, so I am actually kind of hindered today in talking to you because I find that I really won't be able to bullshit. And there are 3 reasons why I won't be able to bullshit. One is that you guys are smart people. Second is that if I try to bullshit, you'll catch me out. But the real reason why I don't want to bullshit is I've got a classmate here sitting right here, and he's going to catch me out before any of you can catch me out. So I have to remain very honest. I also want to tell you that I've been honored by IIT by giving me a doctorate degree, which I don't really have. So I finished my PhD coursework and I did a lot of stuff, but I eventually decided I was wasting my time. I didn't mean it that way. But so I went into working for industry. And when I started to work for industry, or first when I started to do my master's in the US, I was exempted from all the core courses because of the stuff I had done in IIT Madras. So I was able to actually finish my master's coursework very, very fast. So that was a really, really plus thing. And then when I started to work, there are a lot of things that I'd learned at IIT and learned at my college, which was Illinois Institute of Technology, that I was able to use. Is this off? So I'll just talk to you about some of the things that I did. Okay, is it going? Okay, How many of you have seen this number of passes in basketball? How many? So do you mind if I play this? And I'll tell you why I'm playing this once I play it. How do I get this? Is there a volume thing? Anyway, you can read this. Count how many times a player is wearing white pass. Sound? Is there, you have an audio? Okay, let me just stop this. Okay, let it keep going. Just forgive me for not having the audio, but everything is written. How many passes did you count? 13. Did you see the gorilla? How many saw the gorilla? Okay, for 30%. That means you've seen this before. How many who hadn't seen this before saw the gorilla? Okay. Why I wanted to show you this is that we see a lot of things, but we're not aware of them. And we see without seeing. And one of the reasons why you come to college is because you want to become aware of things, right? And once you're aware, that maybe you can use them. And unfortunately, a lot of people go through college without even becoming aware. And one of the things that we're trying to get people to do is value creation. And in value creation, we want people to become more and more aware of things that are happening around them. So let's just keep moving. Some of the things that I learned in my engineering days was that you really have to start looking at engineering from the point of view of fundamentals. Too many of us try to do things with a lot of aids. All of you were born in a time when you had access to all kinds of computational devices. We were at a time, Nagraj would say that, and Narayan Swami would say, we had slide rules. And, you know, sometimes we feel inadequate when we talk to people like you because you're so much smarter than us. But really, we don't need to feel inadequate because we were able to do things with a limited amount of tools. And then you go back to guys who built the pyramids and they built all kinds of things. We really have to admire them because they didn't really have a lot of stuff. So the first thing that I want to leave with you is that fundamentals are very important. And that there is the ability of people to innovate with very few or limited tools and to be imaginative. And the next thing is that when you're working on something, it appears very complex. It appears very difficult. The solution doesn't appear to be very obvious. And it's eventually, when it becomes a reality, it seems like a very simple thing. So I'm going to talk about, one of the things I'm going to talk about is this bottle. It's been around for 40 years. And you all take it for granted. But the kind of grief that we went through in making this bottle become a reality was really unbelievable. So we'll talk about that. But today, you can almost do this in your backyard. And then business has a say in engineering solutions, okay? So the first thing I'm going to talk about is something called suction press roll. So does anyone know what a suction press roll is? Silence. Suction press rolls are a component of a paper machine, and typically they are 60 feet. 60 feet is how many meters? 20 meters long, right? So that would be from where to where? How many meters is this? So it'll be wider than this. They're 6 feet in diameter, 2 meters in diameter, and they're about this thick. And they have a zillion holes in them. And the paper goes in as a felt. It's still in a pulpy moist state, and then there's a rubber roll on top which is called a press roll, and it presses on the felt, and there's a suction box inside the suction press roll, and they're all rotating, and the liquid is sucked out to dry that paper. It doesn't dry completely, but dries a lot. So that's called a suction press roll. We were putting up, I was in the US, I was working for a Fortune 50 company, and we were putting up the largest paper mill in the world in a place called Hodge, Louisiana. And next door to our plant was a company called Cox Newsprint, which was also making paper. And while this machinery was on order, the Cox Newsprint suction press roll failed. That's a major disaster, right? So you don't keep it in stock. It might take you a month to get a new one, or 2 or 3 months. Your plant is down, you're losing money and things of that sort. So our vice president in charge of the paper business decided to look at this whole thing, and he found that there was a fellow called Harry Toby who was the industry expert, and he had done a stress analysis on this, and he said the factor of safety was 4.7. And how do you do a stress analysis? Hey, mechanical guys, sigma equals my by I. Any of you done strength of materials or something of that sort? No? None of them done applied mechanics?
Just Google it these days.
Just Google. So anyway, so he'd done that, sigma equals my by I being the moment of inertia. And then he put a stress concentration factor. And from the stress concentration factor, he said the stresses are so and so, this is in a fatigue mode, and therefore the factor of safety is 4.7. So our vice president, in a moment of weakness, asked, I was in a consulting department in the company, so they had plant level engineering, division level engineering, and corporate engineering, and then they had a super bunch of 10 people, of which I was one, that did very unusual things. And suddenly I was asked to look at it. I was all of 22 years old or 23 years old, and here I was to look at whether this role was going to fail or not. So far, are you with me? Is it so far you can follow me? So, unbeknownst to all of you, for a variety of reasons, one of which was you weren't around 51 years ago, about 50 years ago, or maybe 45 years ago, I put up a photoelastic lab. Anyone know what photoelasticity is? Silence. I put up a photoelastic lab in the Department of Applied Mechanics at IIT. That was my senior project in mechanical engineering. And I did something practical. And I built this photoelastic lab, which was there, I don't know if it's still there, but 20 years ago it was. And what you do there is you take a model and you stress it, and you're able to find out what the stress concentration factors are and stresses are. So I said, let's do that. And this is the kind of lines you get. And from this, you can actually measure the stresses in this thing. And based on this, I said, this suction press roll is not safe. Right? Now, here's the rest of the industry with years of experience saying it's safe, factor of safety 4.7. And here's a 22-year-old kid saying it's not safe. Whom are you going to believe? So there was, the bloody guy, And then suddenly I said, why, in a moment of craziness, I said, let me analyze the second suction press roll, the second machine at Cox, which was our neighbor. And I analyzed that and I said it'll fail in 3 months' time. Now, any of you have done fatigue? None of you have done fatigue. All you guys are so high-tech. I mean, all the simple stuff like fracture and fatigue doesn't exist in your thing, and that's a real life stuff. So all of you who've done fatigue should know or will know that fatigue is a logarithmic thing. So if you're flying in a new plane, the chances of the failure of the new plane in the first year is the same as the chances of the failure of that plane in the next 10 years, which is the same as the chances of failure of that plane in the next 100 years. That makes sense to you? But that's fact, just believe me, okay? So, you can't really say it'll fail in 3 months. The point I'm trying to make is that's all bravado. And I was stupid enough to, and being an IIT guy, you know, you're willing to take a risk and say some outlandish stuff. So I said it'll fail in 3 months' time. And guess what happened? It failed in 3 months and 10 days. And suddenly I was the hero. They all started to believe me. And actually what happened was that the company, you know, the paper industry is a very close industry. They have big problems like this. And they all came to my company to get their suction press rolls designed, and they eventually put up a couple of guys to do that, and I got out of it. So that was one of the first things that I worked on, right? So what have you learned now? You learned about bravado, you've learned about photoelasticity, you've learned about fatigue, you've learned about fracture. Now at least you can use these buzzwords, right? So the next thing was plastic beverage bottles. So let me just give you a little bit of background. I did my master's degree. I went to do experimental stress analysis, which is all this photoelastic crap. But I went eventually into materials, polymers and things of that sort. And when I got into this, into polymers, one of the questions my advisor we had on a quiz, do you call them quizzes or periodicals? What do you call them now? Quizzes. Was what kind of a material will you use for a plastic beverage bottle? And I said polyethylene, which by the way is the absolutely wrong material to use. And I got an A. Because my professor didn't know, I didn't know, none of us knew, but the industry knew that was working on it. And 2 or 3 years later, I was working on that problem. And I said, oh, holy cow, I'm glad my advisor didn't know about plastic beverage bottles, right? So, I don't want to bore you with this, but since I have to show you that there was some real stuff, I'll just do it. It has to hold pressure, therefore it needs strength, should not lose pressure through permeation. So what happens is, if it loses pressure, then you can you've got filled bottles with you, you can't really press them, right? Once you open it, it's easy to press. The other thing that you need, it should not offer an off taste, should not creep under temperature or pressure. So what happens is, you put, and you can try this, you can put this in the sun, and after a few days, the bottle will start to expand and the fill level will start to come down. Never buy a bottle which has been in the sun, okay? And sometimes it has to go through bottle warmers, right? It should have impact strength. It should not shrink while it's empty, so it's stored for some time before it's filled. It should have structural strength for filling, stacking, and transportation, no leaching, and it should be environmentally safe and all that. Now, before I start talking about the base, which is a major thing that I'm going to talk about, I'm going to show you something else. Ooh. Now, none of you who've got filled bottles can open your bottles, right? I mean, I've been told that I'll be thrown out of here and that'll be the end of the talk. But any of you got empty bottles? What happened to the empty bottles? Okay, when you look at this, you'll see little cuts in the thread. Okay, and why is that cut there? The cut is there, you've got an empty bottle, right? Yeah, pass it around. Is there a cut? Cut here? Pass it around. Yeah, pass it around. So what happens is that when you start to open this and it's highly pressurized, when you open it, it can just fly off and hit you in the eye or something. So when you have this cut, the moment you open it, the gas releases and you have no more, you don't have the danger. But more importantly, we reduce the weight of the bottle. Are you guys with me? So if you reduce 0.5 grams in that bottle and you have 15 or 20 billion bottles, how much have you saved in material? There are about 20, 30 billion bottles being sold today. Right? You save 20,000 tons of material. So this was another thing that we did which no one notices. That's why I wanted to show you the gorilla. Okay? So our competition had a base which was the champagne base, and the champagne base is a base that looks like that, but it's about 50% heavier than the base that is in your hand. Okay? So what happened, and that time we were using a material called acrylonitrile. All these bottles that you see are polyester. Okay? And I'll talk a little bit about acrylonitrile and then I'll come to polyester. But the thing about what happened in the polyester business, when the polyester business started, everyone was blowing a bottle which was round, right? When you blow a balloon, becomes round, right? You all know that, right? I don't have to tell you. Nagaraj didn't have to call me here to tell you that a balloon blows round. So what would happen in this two-piece in the polyester game was that you couldn't build this kind of a thing. So you started with a preform, which was injection molded, and then you reheated it and you blew it, not yourself, but the machine blew it, and you blew it into a mold, and lo and behold, a bottle like this came out. But the rest of the competition, when they blew this, they got a round shape. And so what they did was, they put a cup. They put a flat cup, and the bottle had a flat cup. Okay? So we were the only ones with what is called a one-piece bottle, and everyone else had a two-piece bottle. So far, are you with me? I haven't lost you guys? Okay. So, I'm going to go back to nitrile. So, for the nitrile bottles, we needed a 3-foot drop. So, if you drop the filled bottle, it should not burst. But in the nitrile bottles, what would happen is that they would burst at 6 inches. And we had spent, at that time, about $15 million. Later, we spent about $20 million in trying to develop this base. Now, can you imagine, this was in the 1970s, so that's what, 40 odd years ago, what $20 million means in today's money? And what were they doing? They were trying to use, because computers have just come out, not like you guys, you know everything about computers. Oh, we got computers, we can actually do the stresses on this. Huh? So they spent the money doing the stresses. So what they would do is, some joker would sit on the machine, he would design a base, and then that base would get cut. And then the mold would get cut and you'd start making that base. And we kept doing this and kept doing it and nothing happened. We weren't able to improve this. And suddenly, I was picked up to solve this problem. I'd been one of the inventors in the past, but I wasn't involved with this. And my boss told me, So this is another thing you guys have to watch out is what bosses tell you. He said, I think you're a smart guy. You can put instruments into this, instrumentalize this thing, and every time you drop it, you can figure out what happens, what's the spike. There was something called water hammer effect, and there was all kinds of things. And from that, you will be able to decide what to do. And me, like a good soldier, did that for the next 3 months. And one day, I got up and I said, what the hell am I doing? Now, remember, we're still in nitrile, not yet in polyester. So I said, there's something fundamentally wrong in what I'm doing.